Section 2.1 continued, determining function values. Let's start out by looking at a functional notation. Here we have f with parentheses around an x. This is read as f of x. Notice f of x does not mean f times x. And here's an example. When the value of x equals 4, then we would pronounce this as f of 4. What that represents is the value of the function when x equals 4. For example, if I have f of x equals 2x minus 1, we have a value of x that is the input value. F of x is the output value. So from above, if I let x equal 4, I could have f of 4. All I would have to do is substitute the value, or my input value, into x. That would be 2 times 4 minus 1, which would be 8 minus 1, or simplified to 7. My input value of 4 has an output value of this function when f is 4 to equal 7. This is the procedure to be used to solve for functional values. Number 1, we want to copy the problem. Number 2, substitute for the input value. In other words, we want to substitute in for the value of the variable in the function. Number 3, we want to determine the output value by simplifying the problem by the order of operations. Let's look at an example. For the function, they want us to find these given values for our input value. Here we have a function f of x, which is equal to 2 times the quantity of 3x minus 1. So what we want to do is copy the problem, which is going to be 2 times the quantity of 3x minus 1. We want our x value to be a negative 3. So I'm going to substitute that into my function. 2 times 3 times a negative 3 minus 1. Then simplify by order of operations. We want to work on the inside out. Bring down the 2. 3 times a negative 3 is a negative 9 minus 1. 2 times a negative 10 when I simplify inside the function. And then 2 times a negative 10 is a negative 20. So our value of the function, when our input value is a negative 3, I get an output value of a negative 20. Our next one, again, I'm going to have 2 times 3x minus 1. Let's substitute my value of negative 2 in for the variable x. That gives me 2 times 3 times a negative 2 minus 1. Simplify again. 2, 3 times a negative 2 is a negative 6 minus 1. 2 times a negative 7 when I simplify inside my parentheses. And 2 times a negative 7 is a negative 14. So the value of my function when x is a negative 2 is an output of a negative 14. Let's substitute again. When I have a function value of 1/3, I have 2 times 3x minus 1. Substituting, bring down the 2. 3 times 1/3 minus 1. 2, simplify inside the parentheses. 3 times 1/3 is going to give me 1 minus 1. That gives me 2 times 0, which is 0. So when my input value is 1/3, my function output value is going to be 0. Let's look at some more examples. Here we want to find the given value for the functions. Here we're given two functions. We have f of x, which is going to be 2x minus 1. And we have g of x, which is x minus 7. How do we determine which one we use? Well, in the example, it will tell us which one to use. Here we're going to use the function of f, and our input value into f is going to be 2. So I want to use 2x minus 1 because that is my f function. Now, I'm just going to substitute the value of 2 into the function. That's going to give me 2 times 2 minus 1. Recall out here I have a 3. Negative 3 is multiplying my function, so I want to multiply that by a negative 3. I really don't need to write that there as long as I remember that this has to be done at the end of the problem. So I do write it there just as a reminder. So I bring down the negative 3. Work on the inside. 2 times 2 is 4 minus 1. That gives me a negative 3 times 4 minus 1 is 3. My solution is a negative 9. So my input value of 2 solves my function when I multiply by a negative 3 to be an output value of a negative 9. Here, I want to use a function of g. So my g function is x minus 7. So I'm going to have x minus 7. Substituting my input value into the variable is going to be 1. So that's going to be 1 minus 7. I do have something multiplying my g function, which is a negative 1. So I'm going to put that out front. This will give me, when I simplify, a negative 1 times 1 minus 7, which is a negative 6. Simplifying, I get a positive 6. My input value of a 1 and multiplying my function by a negative 1 gives me an output value of 6. Let's continue with the examples. Here we have g of 3. Our input value is going to be 3. Remember, our g function is x minus 7. We just substitute 3 into every variable in our function. So this is going to be 3 minus 7. And when I simplify, that's a negative 4. Input value of 3 into the g function gives me an output value of a negative 4. F of a negative 1. Recall our f function is 2x minus 1. Substituting negative 1 into all my variables in my function is going to give me 2 times a negative 1 minus 1. Gives me a negative 2 minus 1. Simplifying, I get negative 3. Input value of a negative 1 gives me an output value in my f function of a negative 3. A couple more examples. F of 1/2. Our f function is going to be 2x minus 1. Substituting, 2 times 1/2 minus 1 gives me 1 minus 1, which gives me 0. G of 1/2. Remember, the g function is x minus 7. Substituting, I'm going to substitute 1/2 into all variables in the function. Therefore, this is going to be 1/2 minus 7. 3 is multiplying that function, so I'm going to multiply by 3. Simplifying inside the parentheses, 1/2 minus 7 is going to give me a negative 6.5. Changing to an improper fraction to multiply gives me 3 times a negative. 6 times 2 is 12, plus 1 is 13 over 2. Multiplying by 3, or 3 over 1, gives me a negative 39 over 2. Check to see if I can simplify. I can't. Therefore, this is the solution. Here we have a quotient of our functions. Our f function, we recall, is 2x minus 1. Our g function is going to be x minus 7. Then I just substitute our input values for each. For our f function, I'm going to plug in a 2, which is going to give me 2 times 2 minus 1 over my g function, which is a negative 3 minus 7. Simplifying top and bottom gives me 4 minus 1 over a negative 3 minus 7 is a negative 10. Simplifying the problem gives me 3 tenths, and that's going to be a negative 3 tenths. Our last example. Given f of x equals x squared plus x, we want to find 3 times f of negative 2 minus 1. Let's bring down our 3. In place of the parenthesis, I'm going to put a bracket. F is going to be x squared plus x minus 1, and then close that bracket. Substituting our value for x is going to be a negative 2. Bring down the 3. Into my x is a negative 2 squared plus a negative 2 minus 1. Simplifying in the bracket gives me 3. Negative 2 squared is 4 minus 2 minus 1. Simplifying in the bracket gives me 4 minus 2, which is 2, 2 minus 1, which is 1, and then 3 times 1 is 3.